All right, so Unit 3, Day 2. Again, it's Day 2 because Day 1 is already in Schoology. The thought being that, hey, you had 2 days to test, so one of those days was to test, the other was to do Unit 3, Day 1. My guess is many of you haven't done that yet because you were just worried about the test and you got other stuff going on in your life. I get it. But at some point, you need to go back and look at the Unit 3, Day 1 video and worksheet. Right? You got to get online. You got to watch the video. It's only 15, 20 minutes long. It's not a difficult lesson because it's the first one of the unit. But it's out there, and the worksheet's out there, and that's part of what we do. So, yes, this is the first day of in-class instruction in Unit 3, but we're already on Day 2. Rational, meaning ratio, rational inequalities. So all of today's are going to look like f of x over g of x. Because that's a ratio. The steps are pretty similar to what we did with previous inequalities. You find the zeros, put them on the number line, and test the intervals. In fact, that's the steps. Find the zeros. What's a little bit different than previous inequalities is that we have a top function and a bottom function. So we'll just have to find the zeros of both. Once you do that, the rest of the process is the same for inequalities. Set up the number line. So then we're thinking about open circles and closed circles. And after we set up the number line, we'll need to test the intervals. So we'll do 2 examples, and then I'll give you the worksheet, and we'll do one together off the worksheet to kind of jumpstart the homework process. 3x minus 7 over 2x plus 6 is greater than or equal to 0. So again, this looks different than the inequalities we've done before. The process is still the same. Zeros at the top, zeros at the bottom. Put them on a number line and test the intervals. So for the top, 3x minus 7 equals 0. So that means 3x equals 7. So x equals 7/3. So that'll be one of the numbers on our number line. Although I don't want to put it on there yet because I don't know where the other number is. So I don't know where, if 7/3 should be on the right side or the left side. So hold off on that. For the bottom, 2x plus 6 equals 0. So 2x equals negative 6, x equals negative 3. Okay, so now I've got the 2 spots, or the 2 things I need to put on the number line. Clearly negative 3 is on the smaller side of things. 7/3 is positive, so it's bigger than negative 3. For the 7/3, do I want an open circle or a closed circle?
Closed.
Why closed?
It's greater than or equal to.
Yeah, the equal to thing. So closed circle. Because of the equal to. What about the negative 3? The way I'm asking that should make you pause and consider. It's not closed. Even though, yeah, there's an equal sign there. You might know why it's not closed. Well, it comes from the denominator. If you put in -3, that'd put a 0 in the bottom. You can't divide by 0. So if it comes from the bottom is always open. So zeros at the bottom are always open. So you're right to remember that the equal means closed and not equal means open, but that's only for the top. For the bottom, it doesn't matter what it is. You can't divide by 0, so you have to have an open circle in the denominator. In fact, some people like to put it way up here to remind themselves. My red pen to emphasize. Bottom always leads to an open circle. So remember your rule about open, close, and equals, but it doesn't apply to the denominator. All right, let's test our intervals. So a good number less than -3 would be -4. Good number in between would be 0. How about a number bigger than 7/3? 3. Okay, 8/3, but I don't want to use 8/3. 9/3 would be 3, so let's go with 3. Well, I gotta test them all, so I guess it doesn't matter which one I start with. So let's plug in -4. Again, I'm testing into this original to see what's going on here. So 3 times -4 minus 7 over 2 times -4 plus 6. And I'm wanting to see if that's greater than 0. Kind of like we did last time, the most important thing is whether it's positive or negative. So -12 minus 7 is negative something. It's -19, but it doesn't really matter what the number is. It matters the sign. In the bottom, -8 plus 6 would be -2. So that's a positive greater than 0. That's true. Again, the numbers themselves don't matter so much. It matters more about whether it's plus or minus. All right, let's check 0. This should be an easy check. 3 times 0 minus 7 over 2 times 0 plus 6. So the 0 stuff, don't have to worry about. -7, 6 greater than 0. No, a negative number is not greater than 0, so we will not shade there. And then if I check 3, checking 3, so 9 minus 7 is 2. The bottom is all positive stuff, so I don't even have to really worry about it. You can get a little bit lazy on this because you're just concerned with positives and negatives. So positive greater than 0, yep, that's true. So we'll shade over there. A quick word, do you remember the pattern that happened last time we were doing inequalities? It was always alternating, except for double roots. It's the same thing here. You're always going to alternate unless there's a double root. So you can use that to your advantage and maybe check. If you really wanted to kind of cheat the time, you could check one interval and alternate from there. That's a little bit dangerous because what if you make a mistake? I would suggest checking 2 intervals, and if they fit the alternating pattern, then alternate for the rest of them. But it's kind of up to you how many you need to check to feel confident in your answer. Don't have our final answer yet because we wanted an interval notation. So we read our number line from left to right. The answers start at -infinity, and they go to -3. And then they pick back up again, and I'm just reading left to right. I start again at 7/3 with the bracket because it's closed, and head out to infinity. So a lot of the same steps that we've already done. Find the zeros at the top and bottom, put them on a number line, test the intervals. Questions? Let's do another example, and then we'll start the homework together. Example number 2. 2x squared plus x minus 1 over x squared minus 4x plus 4 is less than 0. Well, same process. Set the top equal to 0, set the bottom equal to 0, put them on a number line, test the intervals. Uh-oh, got a factor with the 2 out front. Two x and x. Oh, this isn't bad. It's got to be 1 and 1. That's the only way to make 1. So the only thing I'm worried about is the plus or minus thing. I need the O and the I of FOIL to make a positive 1. So I need a positive 2x and a minus x. So the step that people usually don't show, set the factors equal to 0. Usually students jump straight to answers, which is fine if you're comfortable with that. 2x minus 1 equals 0. That means x equals 1/2. If x plus 1 equals 0, x equals negative 1. So those will go on my number line. Although, again, I don't want to put them on the number line yet because I need to know what my other zeros are to have an idea of where to put them. Otherwise, I end up with, 3 numbers all squinched up on one side. So just kind of hold that thought for a minute. Let's find the zeros of the denominator. X squared minus 4x plus 4 equals 0. So we get x minus 2 and x minus 2, which means x equals 2, although what's special about that one? What's different about that? Yeah, like they're both x equals 2 twice. The fancy math word for that is that's a double root, because it happened twice. That also means I need to be careful when it comes to my alternating rule, because it's not going to alternate across x equals 2. Alright, so let's put our zeros on. So the smallest one is negative 1. The next one is 1/2. And by the way, your spacing doesn't have to be, your number line doesn't have to be to scale. So as long as you get them on there in the right order, it's not like you need to get a ruler out and say, well, this was only this distance, but then I need to move this. No, just put them on in order and you'll be fine. This one kind of works out that there's 1.5 between all of those, so that worked. But generally speaking, you don't have to worry about making your spacing work. You do have to put them on from left to right, smallest to greatest, though. All right, how about 1/2 and negative 1? Are those open or closed? Why open? Yeah, it doesn't include that equal sign, so those are open. So negative 1 is open, 1/2 is open. What about x equals 2? Open or closed? Still open, but why is that one open? Always open. So they're all open, but kind of for different reasons. So x equals 2 is open as well, but it's open because it's in the denominator, and the denominator is always open. I don't have to label this a double root, but I'm going to because I'm already thinking ahead about the alternating thing, and I know the double root's going to mess with that, so I'm going to label it that way. So when the alternating thing doesn't work, I'll remember why it doesn't work, because there's a double root there. Let's see, less than negative 1 would be negative 2. In between negative 1 and 1/2, that's the good one. There's a 0 in there. In between 1/2 and 2 would be 1. And bigger than 2 would be 3. And obviously there's an infinite number of choices there, because there's a million numbers even between negative 1 and 1/2. There's one that's better than most. And so you could pick different numbers there, but most of the time you're going to pick similar numbers to everybody else. Okay, this was going to be kind of annoying, but I got to check it into that thing. So 2 times negative 2 squared. So if I square negative 2, I get 4 times 2 is 8. Trusting you can do a little bit of math in your head so we don't have to write everything down. Plus negative 2 minus 1 over 2 squared is 4, or the square of negative 2 is 4, and then plus 8 plus 4. And I want to see if that's less than 0. So the top I get 8 minus 3 is 5. The bottom, again, who cares? It's positive. So 5 over positive, that's not less than 0. Plugging in 0. This should be easy, because in the top, the 0 wipes out all the x stuff, and I'm left with negative 1. In the bottom, the 0 wipes out all the x stuff, and I'm left with positive 4. Negative 1/4 less than 0. Yep, that's true. My alternating rule is working. What do we think about the next interval? Is it going to be a yes or a no? Based on the alternating rule. No, yes. It should be a no. The double root only affects what happens around the double root. So the rest of this should still alternate. So let's check 1. Although I'm pretty sure it's a no. So if I plug in 1, I get 2 plus 1 minus 1 over 1 minus 4 plus 4. That's an easy check. So that's 2 over 1. No, that's not true. 2 is not less than 0. So we put an X on that one. My alternating rule is working so far, but this double root makes me think this is not going to work. We're not too familiar with double roots, so I should probably test it to make sure. So I'm going to plug in 3. 2 times 9 is 18, plus 3 minus 1, over 9 minus 12 plus 4. And again, I'm really looking for positives and negatives, so you don't have to be perfect on this. 18 plus 3 minus 1 is definitely positive. 20. The bottom, that's a little bit closer. I better be careful here. 13 minus 12 is 1. 20 less than 0. Definitely not. So that's a no. So the reason we picked this example is because it shows that at the double root, the alternating thing doesn't work. It still works everywhere else, but at the double root, it doesn't work. So you can still use the shortcut as long as you know what's happening close to a double root. Let's see. So our answers from left to right, they start at negative 1, they go to 1/2, and we got parentheses on both. All right, the worksheet. On the front, it has review questions mostly. So let's just do the odds on the front. And on the back, we get into some more problems that we need to know. So we'll say we'll do all of them on the back. And we'll do probably 2 of them together. All right, so looking at the worksheet, let's look at number 8. Again, on the front side is odds, and on the back side is all. So that'll cut down some of the extra superfluous problems we're going to worry about. All right, so number 8. Okay, that's not even irrational. That's back to just a polynomial, a quadratic. Except that it's negative. So how do you want to fix that negative? And here's the whole point of this problem. I don't want to factor with that negative there. That's a pain. How could I fix it?
If you divide by a negative, but then don't you have to switch the sign?
Yes, and that is exactly why I picked this problem. I can divide everybody by a -1 or multiply by a -1, either way. That way I won't have that negative x squared, which makes factoring a lot better. And the only price I have to pay is I got to switch that inequality. So -8 minus x plus x squared greater than or equal to 0. So the old rule about if you divide by -1, you got to switch things around. So x squared minus x minus 8 is greater than or equal to 0. Oh man, why don't I like this problem? What am I going to have to do? not factor it is right, because it doesn't factor. So if it doesn't factor, some of you are like, well, if it doesn't factor, it doesn't work. We're just done. But that's not what we're going to do with this one. We would have to use the quadratic formula. And I don't really want to mess with the quadratic formula, so let's stop there on number 8. And let me check the others real quick. No factoring on, or 7, you don't have to worry about at all. 9 will factor. It looks weird, but it'll factor all the way. Number 5, that won't factor. Number 3 won't factor. So what's that leave us with? So on the front, let's do number 1. We already threw out 2 and 4 and 6. So on the front, just do 1, 7, and 9. And that's fine, because those are review problems. So on the front, 1, 7, and 9. On the back, let's do all of those because, goodness, I need to tell Miss Morris that not all of these will work nicely. On the back, let's work number 15 together, because something's different about 15. Looking at 15. Do you recognize yet what's different about 15 compared to the 2 examples we did? Yeah, it has a 1 over there instead of a 0. So we don't like that. Our little 0 tricks won't work if there's a 1 over there. So we need to kind of add a step at the beginning. We could call it step 0. In fact, that's a good name for it, because we need to make it equal to 0. Or greater than or less than. Get 0 on one side. Get everything on one side, making it 0 on the other side. Then we can find the zeros, do a number line, and the intervals. So 15, and then it happens again on 17 and 18. So it's just 15, 17, 18. You got to make it equal to 0 before you can work this process. So I'll subtract 1 to the other side. Hey, that was easy. Except that I can't really do this until it's one fraction over another fraction. Right? Find zeros of top and bottom sort of suggests that there is a top and there is a bottom, and I don't have that yet. The rest of this problem is what we did, or what I did yesterday, how to add fractions. So this is a good one to review. How do you, forget complicated stuff, just how do you add fractions whenever you first learn adding fractions? What's the main thing you got to have? Common denominator. So my denominator will be x minus 1. So I'll put x minus 1 on top and bottom. This is from yesterday's lesson, so that's why it's on this worksheet, is to assume that, hey, remember we did this yesterday. Or at least Mr. Wolf did this yesterday. Careful with the minus 1. Make sure you distribute it so it becomes minus x and plus 1. You keep your common denominator. This is old school fraction rules here. So you add the top, keep the bottom. Clean up the top. Oh, the x's go away. And we just have negative 1 over x minus 1. So this had a lot of work early, but this is not a hard problem now, because there are no zeros at the top. So I don't have to worry about it. There's nothing that will make the top 0. It's just negative 1. There's no values of x that'll work there. The bottom, so is another easy piece, x equals 1. So in the examples we worked, that's where the complicated numerators and denominators were. This problem's hard, not because the bottoms and tops are hard, but because it took a little work at the beginning of the problem to get us there. So x equals 1. It came from the denominator, so I don't care about equal to or not. It has to be an open circle. I mean, even if you were looking at it, you'd get it right on this one anyway, but from the bottom, they're always open. So I'll check 0 and I'll check 2. I can check it in the original or I could check it in this one. It doesn't matter. It's maybe safer to check it in the original. Might be easier to check it in this one. Whichever. Check it in both. I'm going to check it in the original because checking 0 is easy anyway. So negative 2 over negative 1 is less than 1. 2 is less than 1. No, that is not true. All right, checking 2. I'm thinking it's going to work by the alternating rule, but still not sure. Plus, this will be a good check on my work. 2 minus 2 is 0. 2 minus 1 is 1. So 0 is less than 1. Or excuse me, that's a 1 over there. Said the right thing, wrote the wrong thing. 0 is less than 1. Yes, that is true. I don't know why I have to say it out loud to convince myself that it's true. So this one, the answer is from 1 to infinity. All right, to make one of them a little bit easier, let's change number 14. I'm doing all sorts of things to this worksheet. So 17, you'll have to use the quadratic formula. Kind of a pain. Minus 5, minus 15. Yeah. On 14, you would, but let's fix 14. So change 14 to be x cubed minus 2x squared minus 3x. So I butchered the heck out of this worksheet to make it a little bit nicer. So in conclusion, on the front we're doing, what do we say, number 1, number 7, and number 9. Make a note of myself to this. So on the front, 1, 7, 9. On the back, we are changing 14 and just making a note that 17 will require the quadratic formula. All right, and I'll post the answers to this at some point so you can check your work. Reminder that yesterday's stuff is up in the Day 1 folder. This will be in the Day 2 folder.